So the last form of energy that we're going to calculate, we've calculated elastic potential, we've calculated gravitational potential. We then have the useful form of energy, or the used energy, which is really the energy that you would see, and that's kinetic energy. And we denote kinetic energy with this formula over here. So it's equal to EK is equal to half mv squared, where your EK is your kinetic energy, and that's in joules. The m refers to the mass of the object that's moving, and that would be in kilograms. And over here, this is your speed that the object is moving. So speed or velocity, but in physics 20, it's going to be velocity, and that's going to be meters per second. And one thing I do want to say is don't forget to use the square. So let's look at an example of how we would approach these problems. We'll look at two problems here. So example 1. Oops, sorry, I don't know why it's doing this. Sorry, guys. Okay. So example 1. A 1,520 kilogram car is driving at a speed of 30 kilometers per hour. What's the kinetic energy of the car? Okay, so a couple things here. We have the mass, which is 1,520 kilograms, and we have the speed, but the thing is this needs to be converted to meters per second. And in order to do that, we're going to divide it by 3.6. So we divide this by 3.6, and in the end, we're going to get about a speed of 8.33 repeated meters per second. So we have everything that we need. We're just going to plug it into the formula. Our EK is going to be equal to half mv squared, which is equal to half. And for m, we're going to write 1520. The v is going to be 8.3 squared. And so when we plug this into our calculator, and don't forget to put that in brackets, please. Because if you don't put it in brackets, you get some weird numbers. You get a large value, and it's normal because it's a car. We get a car that has about 52,735.56 joules. Now let's say I wanted you to convert this into a 3-digit response, and I want its scientific notation. Well, we'll take that decimal, move it over 1, 2, 3, 4, 5. And so that in scientific notation would be 5 point, and let's do 3 digits, so 5.27 times 10 to the actually, it should be 10 to the 4. So that if we recycle it back here, we want it up to the to the first decimal spot. So 1, 2, 3, 4. So we'll go 5.27 times 10 to the 4 joules. Okay. So now let's do another example. Say example 2. And in this case, we'll draw it as a diagram, and we'll say determine the speed of. And in this scenario, we'll say it's some sort of box that has a mass of 4.0 kilograms. And it's moving this way at an unknown speed. And we'll say that the EK that it gains or that it's experiencing is 100 joules. So this would all be given in the question. Well, what we're going to do is work the algebra out first. So on the side over here, I'm going to write EK is equal to 1/2 mv squared. I can rewrite this as EK is equal to 0.5 mv squared. We'll divide both sides by 0.5 m to remove it from the right side. And then that gives us EK over 0.5 m is equal to v squared, and we'll root both sides just to get v. So now my working equation is going to be v is equal to the root of 100 joules, that's your EK value, divided by 0.5 multiplied by 4. When I plug this into the calculator, a value of about 7.07 meters per second. And if we wanted you to do a 2-digit response, we could say 7.1 meters per second. And these are the answers over here.